we can say that 5 is the most efficient compound. So this is apoptosis studies. As you can see that this is the control, and if you can see between 4 and 5, so mostly 5, you can see more red cell, that is it reacts with yttrium bromide, so more dead cells are there. So you can tell that 5 is more efficient, and that is DAPI stunning. DAPI, this is for the control for when all the cells are alive, and this is 5 where you can see for other some live cells are there, but for 5 the number of the cells are less. So from here also we can conclude that 5 is the most efficient compound. So from this chapter, we just can conclude that we have successfully synthesized and characterized 8 novel metal complexes, and mostly every compound shows distorted square pyramidal geometry. EPR and spectral investigation also shows they retain their identity even in solution, and all compounds can be used as potential anti-cancer activity and can be sent for clinical trial. So this is chapter 4. Here I'll be discussing about some homoleptic complexes. So here we mostly choose some aromatic complexes for the.
But can you please go to the conclusion part? Yeah, this is synthesis, correct?
Yes, sir.
Yeah, synthesis. Then go further. This is metalacycle. Go to crystal. Yeah, very nice. 1, 2, 3, 4. Yeah, go to crystal structure, please. Go to crystal structure.
Okay, sir. This is the crystal structure of the C2. From
Okay.
here,
Then go to next one. Next one.
this is
Yeah.
base binding studies.
Okay.
So
Then please next one.
this is the plot
Okay. Next
from
one.
base
Next one.
binding.
Next one. Next one, boss. Next one. Okay. Fine. Now conclude clearly, please.
We successfully synthesize and characterize a novel series of mononuclear copper-2 complexes of the type homoleptic complexes. And second one, XRD reveals the nearly square planar geometry for C2. All complexes are potent quintet, evident for the BSA binding studies. Then C4 has high binding affinity towards the BSA, and all the compounds have potential biomedical application. So this is chapter 5. So here I'll be discussing about some homoleptic complexes, but these are bulky complexes. So
Boss,
this
go
one,
to chemtran. Yeah. Now this explain, boss. This explain.
yeah, okay. General synthesis of this compound, we have used this. First, we use this benzyl. After that, anisile. After that, acinethoquinone. Then phenanthrolene. Then this one is isatine. With this ketone one, we have introduced one small molecule. Why we introduce this small molecule? Because we want to compare only the donor atom matters, or if in means or the size of the metal also matters, because these are the bulky and this is very small one with a less donor atom. So this is the synthetic procedure for the compound, and these are the structure of the complexes. NMR studies, mass studies, IR spectra. This is UV visible as usual. You can see that 238 to 380, 382. This is for the lambda max. And then this is the UV spectra of the complexes. For the complexes, this broad one is for ligand to metal charge transfer. So this is the crystallographic studies of the one. As you can see, tau value is 0.39 with crystal system big space PBCA. This is the crystallographic studies of the 6. It shows tau value 0.45. The crystal system is monoclinic with space group P21 by C. So, sir, this is BSA binding studies. As usual, we can
Yeah.
observe.
Please go to conclusion, Swamiji, please.
Okay, sir, from this value, we can sir, just let me explain this one, because the
Yeah.
K binding value, sir, if you see the K binding value, we have evaluated the K binding value is very less for the compound 1. As you can see, 2.1, very big for the compound 1. If you see the range 10 to the power 8, and for other compounds, it's in the range of the 4 to 6. So sometimes it doesn't depend on the donor atom. It depends on sometimes the size also, because that the compound was less bulky. Maybe that's why it binds with the BSA very efficiently. So for G value also, as we calculated, we can see this compound 1, it shows most spontaneous process minus 4.74. This also concludes that that when you are designing the metal complex for the BSA binding studies, size also you have to keep in the mind. So conclusion, we have successfully evaluated the chelating properties of the copper 2 complex. Tau value closest to 0 indicates a distorted square planar geometry for the tetragonal one, and ion sensing ability and catalytic activities also could be investigated with this kind of compounds. And according to BSA binding studies, C1 shows most satisfactory result. And within the other five diketo complexes, we have seen the phenothiazine shows the most good result. Why? Because phenothiazine, it has another extra donor atom in that compound. Here I'll be discussing about the mononuclear and binuclear compound. Here we have used phosphine as the
Boss,
co-ligand.
boss, please go to the scheme, boss. Scheme. I thought you already concluded. You are yes. Please explain. Yeah.
This is the scheme, sir. We have synthesized that complex. Should I skip?
Yeah, yeah. This explain, please.
Sir, just we use the copper one complexes. Then we have used this methanol and carbon 2 C phosphate. From here we have done one monomeric complexes, two monomeric complexes, and here we have synthesized two dimeric complexes with S-methyl and benzyl one. Then these are the structure of the complexes. As you can see, these two are ionic complexes, and dimeric complexes, these are neutral complexes. So these are the enamel spectra of the
Yeah,
ligands and enamel spectra of the
yeah, okay.
complexes.
Yeah, skip,
Yeah,
please.
these are
Yeah,
the
skip,
IR
skip.
spectra, UV spectra. Sir,
Yeah,
crystallographic studies.
yeah.
Uh,
Okay.
Tau value is equals to 0.83. That means it is a
Skip, please, please,
distorted
skip,
tetragonal.
boss, skip. Yeah,
Okay.
wait. Skip. Okay, skip.
Okay, this is basic binding studies. Actually, from here also you can conclude that the dimeric compound, because it has the two copper atom, two metal center, it binds effectively with the metal atom. So, if you incorporate more metal, it could be possible. It will be efficiently binds with the BSA. So these are the successfully we have synthesized and characterized novel series of the mononuclear and dinuclear complexes. All are powerful quencher. Copper one dimeric complex had a high binding constant and a high binding affinity, and this also can be used as anti-cancer drugs. So these are the conference and workshop I have attended. These are my publication. I would like to thank my supervisor, M. Felusami, and I also like to thank my collaborator, A. Kathiraban, Mariappan Murali, and Selva Kumar. I also like to thank Sribash Das, Dibyendu, and Kaushik for their assistance in XRD. I also like to thank you, who gives me the time despite of this busy schedule. And I also like to thank our external committee, Professor Atul Saxena and Professor K.M. Rao for internal one, and our HOD, my lab mates, hostel mate, teaching and non-teaching staff, all the research scholar, and for financial one, I like to thanks non-net fellowship and UGC fellowship. Thank you.
Yeah. Thank you very much. Thank you very much. It's a very nice presentation. Okay, you slides are really good. You explained really well. I have only one question. Can I ask? Hello.
Yes, sir.
See, this last one where sulfur is coordinated to the metal, right?
Sorry, sir.
The last chapter, sulfur is
Yes, sir.
coordinated to the metal.
Yes, sir.
Generally, normally we find that type of interaction. What is about that interaction? Generally, we coordinate with the metal, right? Go to the slide, last chapter.
Sir, actually, it's echoing. I don't. You were telling about the last time.
Yes, last chapter where sulfur is coordinated to the metal.
Yes, sir. Should I show you that structure of this one, sir?
Yes. Correct.
Yes, sir.
Okay. Very nice. Okay, nitrogen, phosphorus. Okay, but so among the which higher activity? So far, your species.
Sorry, sir, for my thesis, that IR activity.
Yeah. Higher biological activity. Because we have studied PCC, liver, then metal complexes. So which one activity?
Which one? Which one, sir? For IR activity, which one?
Will be the potential drug molecule. Can potential possibly studied
Sir,
for ligand as well as metal complexes. Correct?
yes, sir.
So
Sir, it's echoing on your side.
okay, ma'am. No problem. Okay,
Sir,
my
okay, maybe I got it. What you were asking? This C3 is more efficient, sir, because
okay,
of the two metal center are there.
okay, fine. Very good. Okay. If people any other questions they can ask. Okay.
Yeah, from audience side, any questions?
One or two questions. Okay, and not more than one or two questions. Only one or two, please. If there is no question, I think we will conclude. It's a very good presentation. I read the thesis really well, written very well. She also presented well. I think I strongly recommend to award the PhD degree to this candidate, and I congratulate candidate as well as Professor Velusamy. Okay, is my senior. Okay, congratulations. Yeah.
Thank you, sir. Sir,
Mm.
give me a smile. I want to take one screenshot.
Yeah, congratulations. Okay,
Okay, sir. Thank you, sir.
okay, thank you. Thank you, Professor. Shall I
Yes, professor. Actually, according to our the university regulation, you need to send your report. Actually,
Yeah. Can I have one more day or two more days? Download and I have to
सर
sign it.
मतलब वो बाहर है हमारे वजह से
तो नहीं उसी का
उसी का
प्रॉब्लम था
प्रॉब्लम है और
वो
सर
शायद ऐसे कई जगह पे तो यहाँ पे इको हो रहा है
और मतलब मुझे तो आधा प्रेजेंटेशन बोलना ही नहीं स्किप
कितना अच्छा ना
अच्छा है ना
हाँ सर ये हाँ सर ये सबसे अच्छा यही है
लेट्स गो बहुत अच्छा था